Hi, welcome back to your new lesson. This is Lakshmikant Tiwari, and in this lesson I'm going to teach about the Seaborn library. So the Seaborn, it will be around the 3 hours long tutorial. I'll be taking a complete Seaborn the crash course, and by taking this course, definitely I bet you will learn almost everything about the Seaborn. Okay, and these are the few things which I'll be doing here. It will be divided into the 5 modules. The first module I'll be covering numerical data plotting, and then I'll be covering categorical data plotting, and then visualization, distribution of the data, and then linear regression and the relationship, and then finally I'll be covering controlling the plotted figure aesthetics, etc. Okay, so there are so much things here. You can see here we will be covering all these things, a different kind of the figures, very nice figures, how we can do all those things, everything. Okay, and this working file will be available on my GitHub repository, and you can visit that and you can download this working file, and you can work on yourself. Okay, you see there are so much things to learn here in this. This will be around the 3 hours long tutorial. Okay, perfect. So let's go ahead and start a brand new tutorial on the Seaborn. Stay tuned for me. Please do not forget to subscribe this channel, and please do not forget to like this video. Okay, I'm gonna invest a lot of the time to make this video, and I'm really very grateful to you are watching my video. Okay, so let's start now. So let's start first importing Seaborn as SNS. So first import here Seaborn as SNS. And one more thing I would like to tell you, that we will be working with the Seaborn SNS, pandas and NumPy, as well as the Matplotlib. Okay, so let's import all those 4 libraries together. So here we are going to import first the pandas as PD, and then we are going to import NumPy as NP, and then import Matplotlib .pyplot as PLT, and then finally I need to write here Matplotlib inline. Okay, so this line will make sure that all the plotted figures should appear after cell execution. Okay, and let's insert few more cells in this Jupyter notebook. You can press escape in your keyboard, and then finally press B on your keyboard. That's mean it will insert some cell in your Jupyter notebook. Okay, so let's press a lot of the B so that we can get a lot of working space here. Okay, otherwise it looks a little weird. Perfect. So we have this one the running. Now our Seaborn, pandas, NumPy and the Matplotlib has been already imported into our notebook. Statistical analysis, the statistical analysis is a process of understanding how variable in a data set relate to each other and how those relationship depends on the other variable. So this is what known as visualization. Visualization can be a core component of this process, because when data are visualized properly, our visual system can see trends and the patterns that indicates a relationship between the variables. With just by seeing a tables and the data, we might not be able to understand the patterns and the relationships between the variables. But with the plots, definitely we will get a better understanding of the relation in between the data and their variables. So we will discuss 3 Seaborn function in this the tutorial. The first one is the relplot, which is relational plot, and then we will go to the scatterplot and then lineplot. After that we will move to the categorical plot. So let's start with loading a data. Now we are going to first load a data, but before I load a data, I would like to set a style here with sns.set, and here we need to set a sns.set, and I need to set here a style, and there are so many options available in style. To know those options, you need to press shift and the tab in your keyboard. You know there By default, style is dark grid. Even though if we don't set, the style will go with the dark grid. Okay, and there are some other options like setting a font and font scale, palette, and style. All those we will see into a figure aesthetics. So let's set a style is equal to the dark grid. Okay, and now we are going to load some data from SNS, load dataset directly. What we need to do here, we need to write here sns.load dataset. Okay, and then we need to write here the dataset which we want to load. Seaborn libraries have a lots of the dataset already by default dataset into a Seaborn library. We just need to load those dataset. We can load with sns.load dataset, and then we can give a name of that dataset. Here we have a tips. Okay, and this returns the data set in form of the pandas data frame, and here we have a pandas data frame which has total bill, tips, sex, smoker, day, time, and the size column. So let's assign this data set data frame into a pandas data frame known as tips. Okay, now we have a tips variable, and now let's see a head of this tips. Here we have first 5 row of the tips, and similarly we can get a tail. Okay, although I have shown pandas pandas data frame working in very detail on the pandas crash course. Okay, so this is how you can get the head and the tail in the pandas. Okay, now let's plot this data set into a relational plot and see how total bill and the tips are correlated together. You see here there is a total bill and there is a tips. Okay, if someone has taken dinner or a lunch, then that person might have given some tip to a waiter, and this is a kind of the relation where we can make a relation and we can find a pattern. What is the probability of getting a higher tip based on the total bill, okay, occur to a customer? So let's go ahead and plot this with sns.relplot, which is relational plot. There we need to provide x, y, and the data set. But before that, let's press shift and the double tab. You will see here a detailed documentation of relational plot, and there you have x, y, hue, size, style, data, etc. We will be taking these in very detail. Okay, so let's go ahead and assign x is equal to the total bill. There we have x is equal to the total bill, and now let's go ahead and assign y is equal to tip, and then we need to assign the data. That's mean we need to provide where these total bill and the tip, in which data these lies, and this lies into a tips, and just press shift and the enter. You will see here by default Seaborn the plot has came, and you see here this is a facet grid. Okay, so this comes inside a facet grid. What we can do, we can write here dir sns dot facet grid and enter it. You will see here the facet grid. These are the things which we can apply on a facet grid, like setting legends, axis, spine, facet axis, etc. We will be taking these things in very detail. So let's come back to this plot. So this is a facet grid. Facet grid means it can plot so many axes on a single figure. If you go and watch my previous tutorial on Matplotlib, I have there explained in very detail grid plotting, where we plots with the subplots. There are so many plots together, like 1 plot, 2, 3, 4, like a plots which is organized into rows and the column. So that is what the facet grid. Okay, we will be taking these in very detail in our coming time in this lesson. So let's go ahead, and you see here we have got the kind of the linear relationship between the tips and the total bill. by your naked eye you can see if bill are increasing, then somehow the tips are also increasing. There is a linear relationship. Okay, and one more thing you might see here, there is the gender, sex, male and the female, smoker, no and yes, and there is day, Saturday, etc., and the time. We can also separate it based on the sex or smoker or day or the time. So let's go ahead and separate this total bill and the tips with the smoker. That we can do with sns.relplot. There I need to provide x is equal to the total bill, and then y is equal to, I need to provide here tip, and then data is equal to, here we have a tips, and then we have here hue is equal to smoker. Okay, perfect. Now you see here we can see how smoker and the non-smoker has given the tips to the waiters, and with this graph we can very clearly see that there are so many non-smoker persons, and the persons the total number of the people smoker is a little less, and that we can get with the count values that we need to apply on the tips. Okay, so here we have the tips, and then we have here a smoker, the time series column, and then we can provide here value underscore counts. With this we can say there are 151% is the non-smoker and there are 93% are a smoker. Okay, perfect. So now let's go ahead and to understand more why we have used this hue. But before that, let me show you once again with shift and the double tab. You see here there is a hue, size and the style. We will be studying these three in very details in our coming tutorial there. You know, initially we have plotted our this figure based on only the two variable x and y. But the Seaborn provided there are many ways in which we can introduce the third, fourth and the fifth variable to understand overall the overall relation between the variables. Okay, and multivariate plotting. So this is how we can understand with the hue smoker, even though we can do with the sex there, male and the female. Okay, and even though we can set with the time as well, dinner and lunch. So this is how we can set with the hue, and we can introduce the third parameter to understand how these variables are correlated. Okay, so it is also possible to represent fourth variables by changing the hue and the style for each point independently. Okay, now let's introduce the style as well. So here in the hue I'm again going to introduce the smoker, and now I'm going to introduce here a fourth variable, that is I'm going to introduce with the style, and this time I'm going to write a style is equal to the time. Okay, so in this way what it is going to do, in this way it is going to show here the total bill versus tips based on the smoker and the style as well. So let's go ahead and see here. Okay, so here we have the total smoker and the time as well. You see here there is color as well as the shape differences. Here we have a color in a smoker, blue and something orange color, but in the time we have black color as well as a cross. Okay, so this is how we can introduce the fourth variable to understand it in the better way. But you know, there is a little difference. There is a little problem. Okay, what is the problem here? Sometimes our eyes might get disturbed by just getting a lot of the information together. So it is always best to keep a simple plot instead of introducing a lot of the information in a complex graph. Okay, So this is how we can represent based on the coloring scheme with the multiple color. But we have also option where we can use a single color with a different intensity. Okay, so let's go ahead and use that semantics here. I'm again going to plot here with the rel plot, that's the relational plot, and then going to give x is equal to, sorry, the total bill, and then I have here y is equal to tip, oops, sorry, then here y is equal to the tip, and then finally here I have a hue is equal to, I'm going to provide here now the size. Okay, so this is the size, and then the data is equal to tips. You see here what happens here. Now we have introduced here the differences based on the numerical value. Earlier there is one more difference, that here we had introduced the third and the fourth variable, and those variables were the categorical, and in that case it will be difficult to just going with these kind of the plotting there. So let's say if we have something like continuous data or a numerical data, in that way we can use a qualitative palettes. Okay, so this is known as a categorical palettes, and this is known as a qualitative. In the qualitative we can change the color gradients or a line width, the circle the circle radius, etc. Okay, perfect. So with this you can see here, there is, if size is increasing, that's mean a darker color, the size is increasing, and then the total bill and the tips are also increasing. There is very the light color is somewhere here, that means the total bill and the tips are a little less when the number of persons are less. Okay, that means here this is the size. Okay, while the people are doing the dinner, so what is the size of their friends? Okay, customer size per table. Perfect. Now let's go ahead and let me ask you a question. Can you change this color? Definitely yes, you can change that color. Let's go ahead and I'll show you how you can change that color with the cube helix palette. Once again we need to go ahead, let me copy this one and I'm going to paste it here, and we can change that with the palettes. Okay, so here we have a palette. You see here there is a palette option. Okay, if you see here the palette name, that is the list or the dictionary, to provide the color. So here I'm going to provide a color in the form of the cube helix palette. I'll discuss this later in this tutorial in detail, what is the cube helix palette. Okay, so let's go ahead with the CH R is equal to minus 0.5, and then we have L is equal to 0.75. okay, so you go ahead and see this color has been changed. Okay, even though you can change this to, let's say, something 9.5, that will make it a little bit more darker, even though you can change this one to something else. Okay, so this is how you can change these colors, right? Perfect. Now let's go ahead and show you how you can change a size of this circle instead of just changing the color of these circles. Okay, that's mean the total, if the tip increases and the total bill increases, then the size of those circles will be a little larger. Okay, perfect. Now let's go ahead and change that. Okay, so in that way what we can do, we can write here sns dot rel plot, and then x is equal to total bill, and then y is equal to tip, and then finally we have data is equal to tips, and then we have a size here, size is size, right? Perfect. So in this way what we can do, this can change. Now you see here the size of the circle, the radius. You know what is the difference here and there? there we have provided this size into a hue. Hue means something like a color changing. If we provide into a hue, it will change a color, right? But if we provide into the size, then it will change a size. And if we provide into a style, earlier we had seen there, then it will change a style. Okay, right? To understand that, what we can do, we can go ahead here and we can type here a style. Okay, you see here with the style, now it is changing. Okay, so this is the different hue, size, and the style. Hue changes the color, size changes the size of the objects, and the style changes style of the represented object. Okay, perfect. Now let's go ahead and make it something the analogy with the Matplotlib. Okay, in the Matplotlib I had shown you how you can work with the scatterplot. In the scatterplot you might have seen something like that, but there is a very complex way to control the size of these points. Okay, but in the Seaborn library we can achieve this controlling of the figures very easily. Okay, excuse me, sorry. Now let's go ahead, and you see here the sizes of the data points are fixed. Okay, let's suppose that if you want to increase these sizes, then how you can increase these sizes. Okay, so what happens actually, these values are normalized. Okay, so we can provide a range in between whose these values will be normalized, then it will automatically increase. Let me tell you how we can do this. Okay, so let's copy this, okay, with the control C, and I'm going to paste it here, and here with the size variable, with the size arguments, I'm going to pass another argument which is a sizes. Okay, so in this sizes it will normalize each of these size parameters. Okay, so here I'm going to provide 15 and the 200. Okay, so here lowest one will be the normalized to the 15 data points, and the largest one will be normalized to 200, and in between these will be normalized somewhere in between 15 to 200. So let's plot it. Once we plot, we can see here now we have a circle with a larger radius. Moreover, we can also increase it a little bit more. Let's say if we make it the 50 and we make it the 500, now we get a little bit larger, more larger. Okay, so let's roll back to the previous one. That was quite good. Okay, so this is the way how we can show a relation between the total bill. I mean, not only the total bill and the tips, but in fact in between the two, the numerical column. Okay, for the categorical, I'll tell you in the categorical data plotting section. Okay, so now let's go ahead. This is about how we can work with this scatterplot kind of the things. Now let's go ahead and I'll show you how we can work with the line plot. Okay, so for time being, I'm going to drop the total the tips data, and I'm going to generate a new data set to plot a line data. Okay, so for that I need to first import a random number. Okay, to do that, what I can do, from numpy dot random. Okay, import random. Okay, so now we have got random. Now I'm going to create a pandas data frame to test our the line plot. Okay, so the df that is the data frame is equal to the pd dot data frame, and then I'm going to provide here x-axis in the form of the dictionary, that is the dict, and then I'm going to create a time here, and that is np.arrange. If you don't know how np.arrange work, please go back and see my the crash course on a numpy. np.arrange, that's the 500 data points, and then finally I'm going to create a value. There the value is equal to the value is column, there is time and value column name. Then this is random, a random value, and the size of random is 500, and I'm going to provide here cum sum, that is the cumulative sum. I have covered these things into my NumPy tutorial. Okay, so let's go ahead and the enter and see this df dot head. It will show you first 5 variable. Okay, so first 5 rows. You see here we have a time and value. These are the column name. So let's go ahead and plot this value against the time. We can do it very easily. So let's go ahead and do with the SNS dot relplot. Okay. One more thing I would like to tell you, in the relplot we have a kind. Okay. So by default that kind is set to a scatterplot, but now here we are going to set that kind to a line plot. Let me show you where is that kind. Here. So by default it is set to the scatterplot, which we have been using earlier, and if we set a line plot then definitely the plot will change. Okay, for time being we can do here also the kind is equal to the, let's say, the line. Okay, so we'll get something like this. Okay, which is really very weird. Okay, so let's go ahead and see here a new data frame plotting it with the kind set to the line. We need to provide our x is equal to the time and y is equal to value, and then here we have kind is equal to line, right? And now we have data is df. Let's plot it. Now you will see here there is a time and the value. So we have plotted value versus time. Okay, and as you see here this is also facet grade, right? Perfect. So this is, you know, there is one more thing, the time. This is a time, and this is plotting this time with the sorting. Okay, so this x-axis is already sorted. Okay, so this time is already sorted, right? Let's say if we do something like if we set here a sort is equal to a false. Okay, then what happens? Okay, sorry, so this is the sort and false. So here we already have a time is already sorted out. That's why we are not getting something like that. Otherwise we might have got something, you know, very wiggly and jiggly data set. What we can do, we can create one more the random data frame to show this what is the mean of the sort. To understand that, let's create once again a new data frame. The df is equal to pd dot data frame, and then I'm gonna create here the random with the random 500 by 2. There we have 2 data, and then I'm going to provide here the cum sum. Okay, so the cum sum based on the x is 0. That's mean there would be only one column will be cumulative summed, and then let's go ahead and provide the columns to this data frame, and I'm going to provide the column as a time as well as a value. Okay, so let's go ahead and see this df head. You see here now we have a time here, but the time is kind of the wiggly jiggly and the time is the not sorted out, right? So let's plot this df. Okay, copy this one and we are going to just plot it, right? So here we have a set the sort is the true. Now we have got something like this. So let's set this sort to false, then what happens? Okay, so we get something like this, a very wiggly jiggly plot. Okay, so this is how we can utilize a sort argument. Let's suppose that you have a data set where your axis, time axis or x-axis is not sorted out. Then you can make a sort is equal to the true, and it will automatically be automatically sorted out based on that axis, whatever axis you provide to x-axis. Okay, perfect. Now let's go ahead and show you something, the aggregations and representing the uncertainty into the data set. This comes, let's say, into a sensor, variable sensors, where for a same value we take a multiple measurements. Okay, so we get multiple measurements, and those measurements are not exactly equal. They are somehow a little deviated from the true value. That is kind of the noise. So let's say if you have that kind of the data, then how we can plot those type of the data into Seaborn. Okay, you might not understand the very well with just the theory. I'll show you that in the detail. Okay, so let's go ahead and load another data set, that is the firm fMRI data. Okay, so this is the default data set available into a Seaborn library data set. So we have fMRI, the SNS dot load data set, and then we have fMRI. There we have SNS dot relplot, and then x is equal to time. Okay, before that I would like to analyze this fMRI. What is this fMRI? Let's go ahead with the fMRI dot head. You see here it has 5 columns. Those 5 columns are subject, time point, event, region, and signal. Okay, so in these subjects we have subject is categorical data, time point is numerical data, event and region is also categorical, although the signal is numerical data. Okay, so let's go ahead and plot this signal. Okay, for the same time there are multiple measurement. So let's go ahead and plot this. If we do this like a normal linear plot, okay, so like here we have, okay, so let's go ahead and see here. Okay, so like here we have a relational plot where we do like that. Let's go ahead and provide here, sorry, SNS dot relplot. There we have x is equal to time point, and then we have y is equal to signal, and then finally we have here kind is equal to line. Okay, and we have here the data is equal to fMRI. Okay, perfect. So you see here what happens. There is a plot, but there is some line there. Okay, so this is the line computed with the 95% the confidence. Okay, so that is the confidence interval. Okay, so this plot shows that if the plot is plotting somewhere this line, that means there is a 95% confidence that the value of the signal at this point could be somewhere in between this and this. Okay, so this is something kind of the confidence interval, and that is the 95% here. Okay, and somehow we can correlate it with the standard deviation. If we have some data, we give some standard deviation and we assume that this is a kind of expected deviation from a mean of that data. So we can consider that in that way. And if you think that this doesn't look good to you, then you can switch off the confidence interval by passing confidence interval Ci is equal to false. Okay, so now Ci is false, and you see here there is no confidence interval, right? And similarly, if you press here the shift and the double tab, sorry, in between the rel plot, you have the Ci. Okay, so here the description of the Ci you will get somewhere. That's the confidence interval. I think we don't have that one, but I'll tell you that in the Ci we can also pass here the standard deviation. Okay, so let's pass a standard deviation, copy this and paste it into a next cell. Okay, And now we are going to pass here SD. The SD means standard deviation. Now here we have a standard deviation for this line plot. Okay, perfect. Now let's go ahead. And so this is how we can plot the data which have a multiple value for the same time. Okay, now let's go ahead, and if we plot these the data without any without this the confidence interval, then what happens? Okay, then what we can do, we can switch that off. So let's go ahead. So let's go ahead and plot it with SNS dot relplot. That's the relative plot, and there we have x is equal to time point, the time point, and then we have y is equal to the signal, and then we have estimator that is none. Okay, so now it will not plot in these kind of the data set. Now it will plot a real data set. Okay, so here it has a none, and then if we pass here kind is equal to the line, and then finally the data is equal to fMRI. Okay, you see here we have got this data very wiggly jiggly, and earlier we had a data something like this. Okay, so that was a kind of a very fitted data with a very high confidence, and with some standard deviation. Okay, perfect. Now let's go ahead and plot this data with a semantic mapping. Okay, like we did into our scatter plot in this tutorial. We had hue, size, and the style. The same way we can do here. Okay, let's go ahead and plot that. Perfect. We can type here the SNS dot relplot, and then we have x is equal to the time point, and then we have y is equal to signal, and then we have here hue is equal to event, and then finally we have here kind is equal to line, and then finally we have data is equal to the fMRI. You see here, to make it a little bit more clear to you, what I can do, fMRI dot head. You see here what I have done here, I have added a hue parameter. Okay, so hue parameter, earlier I have told you, with the hue you can change a color, with the size you can change a size, and with the style you can change a style. Okay, so here I have provided a categorical variable that is event, and I have two type of event in my data set, that is the stem and the queue, and based on those events it has classified those data into the two part. Okay, so this one blue line is stem type of the event, and here this one is a queue type of the event. Okay, so this is how we can make we can differentiate different kind of the plot based on the categorical the category. Okay, and similarly we can go ahead and we can provide with the style as well as other parameters. So let's go ahead and type here SNS and then relplot. There again I'm going to provide here x is equal to time point, and then I have y is equal to signal, and then I have here hue is equal to region, and then I have here style. Okay, so here I have a style is equal to event, right? Perfect. And let's go ahead, kind is equal to line, and of course I need to pass here the data is equal to fMRI. Okay, you see here I have provided now hue based on the region. So we have two type of the region, peripheral region and the frontal region. Okay, And then after that I have the event is the stream and the queue. Okay, so you see here style. Now based on the event, the line style has been changed. Okay, and based on the hue, the color of those lines has been changed. Okay, so this is how it is being done here based on the hue and the style. Now we are left with the size. Okay, so I'll take that size also later. Now let's go ahead and do something with the styling a little bit more. Okay, by placing a marker on these data points. Okay, that can differentiate in a more better way. In general, what happens, our human eyes are not pretty much able to distinguish complex data and a complex figure. So it's always recommended to make a complex figure and represent it into a simple way. Okay, so let's go ahead and provide some, you know, a little bit more styling. So I'm going to just copy this cell and I'm going to paste it here with Control and the V. There we have now hue region, and the style is event, kind is line, and data everything is ready. But here I'm going to provide few more the arguments like markers. Okay, so here I'm going to provide the markers. The markers is the true, and now let's plot it. Once we plot it, we see here now we have a different type of the marker for different type of the data set. Okay, and apart from these markers, we can also provide the dashes line false. So these dashed line will be false. Okay, so we can say here dashes is equal to false. Okay, perfect. Now this dash line is false. Now I am sure this the plot has become a pretty much complex. Okay, so we should not make it more complex, so that instead of giving it benefit, it should not go in the bad way. Okay, as with the scatter plot, be cautious about making the line plots using the multiple semantics, otherwise it makes it very complex. While sometimes informative, they can also be difficult to parse and interpret. But even when you are only examining changes across one additional variable, it can be useful to alter both the color and the style of the line. This can make the plot more accessible when printed to black and white or viewed by someone with the color blindness. So let's go ahead and plot it in that way. Okay, so let's go ahead and paste it, my earlier the copied cell here. Now here we have x is time point, y is a signal, hue equal to event. Okay, and let's make a style here with the event, sorry, hue, yeah. So here you have hue as an event, style as an event as well, kind is line, data is a permi. Okay, let's see what happened here now. Now if we plot here, we get a different kind of line as well as with the color. You see here, earlier we had, if we had just a hue, then what happens, you see here, with just a hue there is just the color change, and with only style there is just a style change. Okay, but if we add our hue as well as the style together, then we have a color as well as a style change both together. Perfect. So this is how we can put an emphasis more on our figures. Now when you are working with the repeated measures data, as we had seen earlier, then you can also plot each sampling unit separately without distinguish them through semantics. Okay, this avoid cluttering the legends and all those things. What I'm trying to say here is that, let's say here I have so many data plots like this. Okay, so these data plots are very wiggly jiggly. So what I can do here, I can plot these multiple lines together, multiple measurements together. Then to plot those multiple measurements, what I need to do here, I need to work with the SNS, then then dot relplot, sns dot relplot, and x is equal to, we have here the time point, and then we have y is equal to signal, and then finally we have here hue is equal to region. Okay, and then the units, which the units I'm going to provide there, that is the subject. Okay, that's mean for each subject this is going to be a different different line. So this is going to be plot a different line. So if you have forget what I'm talking about the subject, so let's go ahead and type here fMRI dot head. You see here, sorry, you see here for different subjects we have the measurement. Now we are going to plot these subjects separately. Okay, so let's go ahead and plot it with the unit subject, and then I'm going to also plot I'm going to set estimator. Okay, estimator is equal to none, and then this is kind be this is going to be line kind, and then finally we need to pass here data, and that data is fMRI. Perfect. So let's go ahead and see what happens. Now here we have the very wiggly jiggly line again, once again. Then what we are going to the set here, we are going to just take a fMRI event, only those which are stream type. Okay, so what we can do, that we can now provide the data is equal to fMRI dot query. Okay, so this is going to take all the data which satisfy the conditions given by me, that is the event is equal to stream. Okay, so this will only plot only those data whose event are stream. You see here the stream type. Okay, it will not plot the another type which was queue. Okay, so let's go ahead and plot it. Sorry, somewhere it is saying that we have the invalid syntax, perhaps this one. Okay, here I'll tell you what happens. So sometimes what happens when we give a string inside a string, then we need to use these the single inverted and the double inverted as well together. Okay, now let's go ahead and plot this. So here we have now our measurement for each subjects. Okay, this is the how we can plot the multiple measurements for different type of the subjects together. Okay, so now let's go ahead and understand what is the default color mapping here. So this is the default color mapping set to this one. Okay, so this is the default color mapping set to this one, and now I'm gonna change this with something more innovative way with the relational plot. So let's go ahead and load another data set. That data set is the dots. So here we have dots is equal to the sns dot load data set, and now here we have here dots. Okay, so let's go ahead and see the dots with our head. You see here we have a total of 5 columns. Those columns are align, choice, time, coherence, and firing rate. Okay, and out of these 4 there are 2 columns which are categorical type and 3 columns are numerical type. Okay, perfect. Now what I'm gonna do here, I'm gonna even going to make it a little bit more precise. I'm gonna say here the query, that is gonna be here align. Okay, lign align is equal, sorry, once again I have made a little mistake here. I need to put here a double quote, and inside that double quote align is equal to, if it is equal to dots, then only then it will work. Okay, sorry, it will get all the data. Perfect. Now let's go ahead. We have got over the data dot. Let's go ahead with the sns dot relational plot. So here we have sns dot relplot, and then we can provide here x-axis, that x we have at the time, and then y On the y-axis we have a firing rate, and then with the hue we can control the color. Okay, so the color of the parameters, that is the coherence, and the coherence is kind of, you know, now it's a numerical value, so for each value it's you know, the color will be changed. What I'm gonna do here, I'm first gonna just plot it without any hue and size, etc. And then finally I'm gonna set here the data. The data is dots, and perhaps I have also missed the kind is equal to line. So let's plot it and see what happens. So we have something like this, right? So we have something like this. There are very, you know, the multiple measurements here, and for each that could be for the choices, for each choices. Now we are gonna make we are going to differentiate with the hue and the size. Okay, so let's make a hue is equal to the coherence. Okay, so here we have a coherence. Now let's see here, we should have a color changed. Okay, although I have not this here you see we have a color change, although I have not made a difference between based on, sorry, I have not provided a style semantics here. So let's provide a style semantics first. Okay, so for a style semantics I'm going to provide here a choice. Now you will see so many other, you know, the different kind of the kind of plot. Okay, so these are the line how we can get you know, the styling based on the categorical plot as well as the numerical, sorry, categorical data as well as a numerical column. Okay, so here you see here hue is a numerical column, and choice is categorical here, and now this has a different style as well as a different color for different type of the data sets, that is the choices. Okay, so sometimes what happens, even though the hue variable is numeric, it is poorly represented by linear color scale. Sometimes, you know, color blindness might the people with the color blindness might get confused. So that's the case here, where the levels of the hue variable are logarithmically scaled. You can provide specific color values for each line by passing a list of the dictionary. So there are so many lines, and 1, 2, 3, 4. So there are 4 lines, and we can provide here, you know, the different color, the color palette. So earlier I had mentioned you that I'll talk more about this color. So let's go ahead and create a color palette. There is a palette with the sns.cubehelix. Okay, so here we have sns.cubehelix palette. There I'm gonna set here a light, intensity is 0.8, and the number of colors which I'm gonna get here, that is the 6. Okay, perfect. And I'm gonna copy this, and then again I'm going to pass it here with the another parameter, that is the palette. Okay, so here we have a palette is equal to palette. Now let's go ahead and plot it. So there you see here a little bit more color changes has been occurred there. So even though if we set light 0.5, you will see here now the darker color has been appeared. Okay, so this is how we can control these color changing and its darkness and the lightness. Okay, we have also some other methods where we can where we can also change the size of these lines, etc. So let's go ahead and show you how you can change the width of these lines based on their intensity. Okay, so to do that you can do sns.relplot, and then you can do with x is equal to the time, and then y is equal to firing rate, and then we can do with size is equal to coherence, and then finally we have here style. Their style is equal to choice, right? Perfect. Now we have got the kind is equal to line, and then finally we have here the data is dots. Okay, so let's go ahead, and you see here, since we have provided size, the coherence to the size argument, now it will change the line width based on the coherence value. Okay, perfect. We can also map these with the sizes. Okay, so let's go ahead, map it with the sizes. Now I'm gonna map it with the 15 to, let's say, 100. You will see here the line width has been changed drastically. So let's change it to 1 to 10, in between 1 to 10. So this is how you can change the line width as well. Okay, perfect. Now let's go ahead and show you how you can change line width as well as its its color as well. To change its color as well, we need to just pass here a hue. Okay, so just pass a hue, and now we can pass a hue is equal to coherence. Okay, perfect. So here we have a coherence, hue equal to the coherence, as well as size equal to the set to the coherence. So in this way we can make a changes, as well as we can set here the sizes to the choice. And there, now the size will change according to the choice, and right, perfect. So there are only the two the type of the plot, two type here of the line width, and I think now this doesn't matter there, so we can remove that, and it will show something like this. Okay, yes, definitely that matters. It has a scale that 1 and 5. Perfect. Now let's go ahead and show you how you can do the plot with the the date. As of now, we had a plot with something like numerical data, which was like a numerical 1 2 3 4 5 kind of that. Let's suppose that once you have a data which is if its column or the x-axis is a time format, that's mean a real date, like 4th of June of 2019 kind of that, then how would you plot that? Okay, to do that, let's first create the data set with the date and the time. So we can do with the pandas data frame, df is equal to the pd dot data frame, and then we can pass a dictionary, that is the dict, and then we are going to pass here a time column. In the time column, I'm going to create a date time object with the pandas, that is the pd date range, and that date range is gonna be 2019. Okay, the 2nd June of 2019, and there is going to be total number of periods, that will be a day, and that is the 500. Okay, so approximately less than 2 year, 500 day. Right, now I'm gonna set here the value, that's the value column, and in the value column I'm gonna create a random number with the randin. I have already imported randin from numpy.random. Then it has a 500 value, let's say. So both time and the value have a 500 value, and then I'm gonna put it cumulative sum. Okay, that's the cum sum. Perfect. Now we have our data frame df. Let's visualize this data frame df. So here we have a date 2 June, 3rd June, 4th, 5th, and the 6th June. Now my question is, how would you plot this data? Okay, value versus time. Okay, so this is really very simple. What we are going to do here, we are going to do here sns dot relplot. Okay, as usual we do. Here we are going to provide here x is equal to the time and y is equal to value, and then the kind. Okay, the kind is equal to line, and the data is equal to df, the df. Okay, so let's plot it. So once we plot it, it says that this time has got mixed up. Okay, so this time has got mixed up to each other, and it's very wiggly jiggly. So what we can do here, we can get an object since it returns a facet grid. Okay, so let's get this facet grid into a G object, and what we are going to set here, we are going to set a property of the the auto formation of the date into facet grid. So the G dot and then the fig underscore auto, that's that it will automatically format auto fmt with the date, okay, on the x-axis. Now you see here it will automatically reformat. Sorry, the something has gone wrong here. This should be the fig dot auto format x data. This says that the figure object has no attribute auto fmt underscore x. Oh, sorry, this should be the date. Okay, x date. Perfect. Now this has value versus time. So this is how you can plot the variable against the data, the time. Okay. Now let's go ahead. We have been talking so much about the facet. So what is the facet? Now the question is, what is the facet? I have earlier told you that with the facet you can plot multiple plots simultaneously, like we have plotted into Matplotlib tutorial. There we have used subplots to plot multiple plots together. But here into the Seaborn we can plot that with the facet as well. Okay. So let's go ahead and visualize our tips data, which earlier we had. Okay, so earlier we had tips here, and the tips had the total bill, tip, sex, smoker, daytime, and the size. So let's go ahead and create a relational plot there, sns.relplot, and then we have x is equal to total underscore bill, and then we have y is equal to tips, sorry, y is equal to the tips, y is equal to the tip, and then we have a hue is equal to smoker, and then we have call is equal to time, and then we have a data. Now on the data we have a tips. Since now let's go ahead and you see here, now in the facet grid there are two axes, the axis 1 and the axis 2. You see here what happens here, it is almost a similar kind, okay, but here this is the extra parameter which we have provided. So let's cut out this parameter and see what happens. Okay, we again get just a single parameter, but if we introduce this column, okay, and the column is based on the time, now we will get two different parameters for one time and the another. Okay, perfect. And similarly, let's copy this and paste it here, and if we change this, the column based on the time, let's change it to the size, then what happens? Let's see. Now there are so many sizes, 1 2 3 4 5 6. Okay, so there are 6 sizes. Now we have got there 6 figures. Now here there is a little problem. There are so many figures, and these figures are aligned to a row. Okay, now we have another methods in which we can control these wrapping. Okay, so I'll tell you that later how you can do that, and that can be done with the column wrapping and the row wrapping. So I'll tell you that later. So now let's go ahead with the many more facet variables. Now this time what I'm gonna do, I'm gonna plot a 2 by 2 matrix. Okay, and those 2 by 2 matrix will be based on the region as well as the event and the subject. Okay, so let's go ahead and do that. Okay, and if I pass here, this is the column, the size. If I pass here a row, now this will be set into a row. Okay, so this is how we can do this. Okay, now let's go ahead and see how we can plot a 2 by 2 matrix. Okay, 2 by 2 facet grid. So we can do with the SNS dot relplot, and then we have x is equal to time point, and then y is equal to signal, and then we have a hue is equal to subject, and then we have a call, and in the call we have a region, and then we have a row. Here we have row is event, and then here we have a height is 3, that will set a figure height, and then we are gonna set here the line is, of course, is gonna be a kind of line, and estimator, okay, estimator is gonna be none, otherwise it will calculate confidence interval, and then data is equal to fMRI. Okay, so with this, what I'm going to do here, I have plotted a 2 by 2 facet grid. In the first row, you see the row has been managed with the event type, and those events are the queue and the stem. So you see here, this row is based on the queue, and the upper row is based on the stem, and the column, these columns are categorized based on the region. So we have two regions. This is the parietal region. So the parietal region is the first column, and the frontal region is the second column. Okay, so this is how we can control the rows and the column based on by setting the arguments are the parameters of column and row. Okay, now let's go ahead and discuss how we can control this. Okay, so which earlier we had, let's make it call. Now how we can wrap it into let's say the 2 by 3 matrix. Okay, let's copy it. I'm going to copy it and paste it here. Then what simply we can do here, we can pause, we can pass here a column wrapper. If you press here shift and the double tap, you see here we have a column wrap. Okay, we can pass here call wrap. Okay, now the call wrap, I'm going to pass here a 3. Now the column will be wrapped into the 3 by 2. Okay, although I have not passed here a height, then it will automatically adjust the height. Otherwise I can also pass here a height. If we pass height equal to the 3, now it will adjust the height according to the parameter, okay, passed to a height. Perfect. So these visualization which are these visualization which are often called lattice or small multiples are very effective, because with these only the facet grid we can visualize so much things. Okay, with this we can understand how size 1, 2, 3, 4, 5, 6, right? So these are how it is varying. You see here in the size 6 there are very less total number of bills and the tips. With this we can understand size 2, size 3 and the size 4, they are very high density, although the people are tend to go in the couple, that is the size 2, and there are few people who also go with the like a friend circle with the 3 or the 4, but it's very rarely likely that people go with the 5, 6 or a single person. Okay, so this is this gives you a very broad way to visualize instead of just passing data in the form of the table. Okay, so this is the how we can visualize the line plot and the scatter plot with the help of the relational plot. Okay, now I'm going to show you how you can do it with the relational how you can do it with the line plot. Okay, so it has also SNS.line plot. You see here it has a line plot. If you press here the shift and the double tab, you see here it can also get X, Y, hue, size, everything. Okay, so similarly we can go ahead and pass here X is equal to, let's say, the some data. Here I'm going to pass here the total bill, total underscore bill, and then I'm going to pass here Y is equal to the tip. Okay, and the data is equal to the tips. You see here I get also a similar kind of the plot, but in the form of the line. Okay, if I set here the scatter plot as well, so I'll get something like I got the earlier, okay, in this tutorial, okay, before sometimes in our early minutes of this tutorial. So this is how we can take the advantage of the line plot and the scatter plot together into a relational plot as well. Okay, perfect. So perfect. Now we have done with SNS a relational plot. Now I'm going to show you how you can plot these data with the help of line plot as well as a scatter plot. Okay, so let's go ahead and first see a line plot, how we can do with the line plot. Now we have our Fermi data. Okay, so let's go ahead and see with the head. fMRI data. So here we have these 5 columns: subject, time, events, and the region signals. Okay, now go ahead and work with the line plot. There, what we need to do, SNS dot line plot, and then I need to pass x value. In the x, I'm gonna pass here time point, and then in y, I'm gonna pass here a signal. Okay, perfect. And now in the data, I'm gonna pass here fMRI, right? You see here, now we have got a plot here, right? Perfect. So you might remember that this plot we have also got with our relational plot, rel plot. Okay, so earlier in our plot, relational plot, we have got similar like this. Now what I'm gonna do here, I'm gonna change this plot using a hue as we did in our previous tutorial. So let's change with the hue, and in the hue I'm gonna pass here event. Okay, now we have got here a hue. Okay, perfect. And similarly we can pass here a region. Okay, sorry, we can pass region. So with the region we have also 2 line plot. Okay, perfect. Now let's now let's go ahead and add a hue as well as a style. Okay, perfect. Now here we are gonna put a style. Now the style is equal to, we are gonna put here event, right? Now you see here we have 4 different type of the line, and with their the hue, okay, along with the region. So that's why we have a 2 different color along with the 2 different type of the style, and that is the event. Okay, perfect. Now let's go ahead and work with the marker here. Now I'm going to show you with the marker as well. Here I'm going to put here markers is equal to the true. Okay, so if you remember the previously we had done almost the similar thing. Now it will place a different kind of the marker on each of these different kind of the plots. Okay, and similarly what we can do here, now we can also put some kind of the error plot, sorry, some kind of the error, and we can set a CI, which is the confidence interval equal to the null. Now there is no confidence and there is no the shaded lines. And apart from that, now we can also set error style in this our line plot with the error underscore style. There in the error styles we are gonna set here a bar. Now these bar, with that we need to set a CI with some numbers. So let's set it to 50. Okay, now you see here, and let's set it to 68, some random number there. You see here, now we have got something like this. Okay, so this is approximated error, and if you remember that in the CI we had something like this. Okay, there was a shaded line. So this is approximated error. I mean, this line could be somewhere in between this and that. This line could be somewhere in between this and that. So this goes like so on. Okay, perfect. Now let's go ahead and plot these multiple data, I mean for multiple subjects into a different lines. Okay, how we can do that? We can do that SNS dot line plot, and then we can say x is equal to time point and y is equal to signal, and then we have a hue is equal to event, and apart from that we have units is equal to subject. Right, now we have here a estimator is equal to the none, and apart from that we are gonna set LW, okay, keywords equal to the 1, and the data which we are gonna pass here, that is fMRI, and we are gonna just pass a single region here. So we are gonna get here a region, okay, and that region equal to frontal. Okay, perfect. Now let's run this. Now we have here multiple lines together. So this is almost a similar kind what we have seen in our previously in this lesson in our relational plot, okay, into our rel plot. And similarly we can do with these lines with the dots, like multiple lines. Let me show you what I'm talking about with the dots here. So similarly we can plot these lines, and we can bring these the legends inside these graphs. Let me show you how we can do that. Here we have our dots dot head. Right, now let's go ahead and we are gonna do here SNS dot line plot, and then x is equal to time, and then we are gonna pass here y is equal to firing rate, and similarly here hue is gonna be coherence, and apart from that I'm gonna set here a style is equal to choice, okay, and then data is equal to dots. Perfect. Now let's go ahead and run this. Let me see what is the error. Could not interpret here the coherence. Perhaps this is the wrong. Now it should be right. Okay, so we have got something like this. Perfect. That's the fantastic. So this is all about this line plot, and similarly we can do with this scatter plot. Let's go ahead and work with this scatter plot. Now I'm gonna do starting with here. So we already have a scatter plot for our tip versus to total wheel versus tips. We can do, of course, like this SNS scatter plot, and we can set here x is equal to the total underscore bill, and similarly we can set y is equal to the tip, and then we can pass a data is equal to tips. Right, so this is how we can set a scatter plot, and similarly we can, you know, set here a hue based on a sex. There you see there the male female, and you can set it based on also a smoker, right, sorry, and similarly we can set here a size is equal to the based on their size. Now you see here these the size has been changed, the circle size has been changed for a smoker as well as a size, and this is a hue and size, and similarly we can also change the style based on something, although we are not going to do. Okay, perfect. Now let's go ahead and check with the style as well. Okay, so with this style let's pass a time there in the style. Okay, now we have got here a size, style, and hue as well. Okay, perfect. So now you might be very assured that whatever we can do with the SNS dot the rel plot, that's the relational plot, we can do almost everything with the SNS dot scatter plot and linear plot. Okay, perfect. Now let's go ahead and work with the different the kind of the data set which is known as iris data set. So let's load first this iris data set with the SNS dot load data set, and we can type here iris, and then finally let's visualize this iris with Pandas head. Here we see we have a total the 5 column. So the first 4 column is sepal length, sepal width, petal length, and petal width, and then finally we have a 3 type of the species. Okay, perfect. Now let's go ahead and plot this. We can do with the SNS dot scatter plot, and I'm going to pass x is equal to iris the sepal length. Okay, and although we can either do like this one or let me show you what I'm going to tell you. We can pass something like this. Okay, sepal underscore length, and similarly we can pass y. Y is equal to, let's say, petal length. Okay, underscore petal length, and here we have a data is equal to iris. Perfect. Now let's see. So we have got something like this. Okay, so the sepal length is increasing, the petal length is also increasing, and if you don't want to pass this data in a separate argument, then what we can do, you can do SNS dot scatter plot, and then we can pass here x directly with the iris sepal length. Okay, so we can do like this, iris sepal length, and then y is equal to iris, and then petal length, right? So here we have something like this. There we have a sepal length and the petal length. Perfect, right? So these plots is almost similar to the earlier one. So these are the way in which we can plot this. Okay, now let's go ahead and discuss about the data visualization of a categorical plot. Okay, do you remember in our initial while I started this tutorial, I told you that we will start the categorical data plotting like this. So let's copy this one. I'm gonna copy this categorical plot, and then at the end I'm gonna paste it here. Okay, perfect. So in a categorical data plotting, we can plot the category. Okay, so let's say here we have a tips dot head. So like this, the sex, smoker, or the time. Otherwise, let's load Titanic data. Okay, this Titanic data with the SNS dot load data set. Okay, so now here we have our Titanic data. Now let's visualize this. So you see here we have so many the column like survived, P class, sex, and then we have class and embarked, then adult, male, deck, etc. So these are the categorical plot. Then how would you analyze these categorical plot? How would you draw these categorical plot? So for these plots we can draw and visualize our data using catplot, boxplot, stripplot, and swarm plot. Let's go ahead and see how we can do. Perfect. So the first we are gonna use catplot. Okay, so the first I'm gonna use a catplot. The default representation of the data in the catplot uses a scatterplot, and there are actually the two different categorical scatterplot in the Seaborn. They take different approaches to resolving the main challenge in representing the categorical data with a scatterplot, which is that all of the points belonging to one category would fall on the same position along the axis corresponding to the categorical variable. Okay, and the another approach is used with a stripplot, and where default the plot kind is a catplot. Okay, so let's go ahead and first load a tips data. In fact we already have a tips data. Let's go ahead with the sns.catplot, and then we are gonna pass here x is equal to the day, and then finally we are gonna pass here y is equal to the total bill, right? Now we have not passed the data yet. Okay, so this is how it's gonna work, right? You see here now we have x, y and the data, and this is a kind of we can do like this categorical plot. We have never seen like this plot in our earlier tutorial there. So this is a kind of also a scatter plot, but now it is being plotted with the category. Okay, earlier we have a scatter plot that was being plotted on the numerical data, but now this scatter plot is being plotted with the categorical data as well and numerical data. So the x-axis is here a categorical data and y-axis is a numerical data. And similarly, if you want to interchange, I mean this is kind of the vertical challenge. Let's say you can interchange this x and the y. Now you will get a horizontal line there, right? Something like this. Okay, so these things you can always do. Now let's go ahead and the replot our vertical the data. Now in this way you see there is a jitter. Okay, I mean there is jitter. These lines are a little deviated from the mean. If you want to remove those lines and you want to put these lines in just a straight line, there is a the method which you can argument which you can pass, a jitter argument. Okay, if you pass this jitter argument is a false, then this will be aligned into a very straight single straight line. Okay, perfect. The second approach adjusts the point along the categorical axis using an algorithm that prevent them from the overlapping. Okay, so you see here this is the overlapping and it was used to prevent the overlapping. Okay, so that kind of the plot sometimes called as a swarm plot, which plots the different kind of the different kind of the plotting. Okay, not like this. Let me show you what I'm talking about here. So let's go ahead and type here sns.catplot x is equal to the day and y equal to total bill, and if you press here shift and the double tab, you will see here a kind. Okay, let me show you here somewhere. This is the kind. Okay, by default kind is a strip plot, and now we are gonna do a kind is equal to the swarm plot. Okay, so here we have a swarm. Okay, sorry, just a swarm. Okay, so you see here these are the different. So now we have got a three different type of the data plotting here. The first one is a very straight line, and the second one is has a little jitter, and the third one is kind of the swarm. Okay, it's a kind of the tree. Okay, so similar to the relational plots, it is possible to add another dimension to the categorical plots by using a hue semantic as well. Let's go ahead and add a hue semantic here, and the hue semantic I'm gonna add here a 6 and see here. Now this is completely insane. Okay, perfect. So Seaborn gives us gives us a lot of the control on the plot, and we can really make a fantastic type of the plots. Okay, now let's go ahead and apart from this we can also the plot based on the size as well. Okay, go ahead. Sorry, we need something in a size, and I don't think we can do a size. Okay, so we can't do with the size, and can we do with the type? Sorry, we don't have any the type here, but we can get with shift and the kind there. So we have there hue only, but we doesn't have any other type. Okay, size and the style we don't have. So let's go ahead with the hue only. Okay, perfect. Now let's go ahead and plot only the two categories, like a smoker and versus tip. Then how we can do. And one more thing you might be wondering, how these the axis numbers are being fitted here. Okay, so by default it takes the first which axis comes first, like a Thursday, Friday, Saturday, Sunday. Similarly, what I can do for you, I can show you a very practical example with the cat plot. Here I have x is equal to smoker. Okay, and here I have y is equal to tip, and then I have data is equal to tips. Okay, so let's plot it. You see here the first has came S and there is no. Okay, now let's go ahead and analyze these tips. Okay, head. You see in the smoker it has got first no and then S. Let's say if you want to adjust this order and you want to bring this no first and then yes, then of course you can do. Okay, how you can do that? You can do something like this. You can put here a order, and then you can say the order. The first order is gonna be no, and then second order is gonna be S. Okay, perfect. I think something is wrong here somehow. Let me see. This says that sorry. Okay, you see here now we have got first no, and similarly we can say here non-smoker as well. See here non-smoker. Oh sorry, if it doesn't get, then it will not show there. Okay, so we get no, and then no is aligned here, and S is aligned here. Perfect. Now let's go ahead and now how we can plot it into a different kind of the distribution. Okay, so in this way you see here the one thing what we are missing here, we are missing that we can understand that there the most of the total bills are concentrated at this point here, and here at this point, and here at this point. But what we are not getting here, a full statistics we are not getting, right? Like what is the percentage of the total, how much 50% or 70%, and what is the maximum and the minimum, and other type of statistics like mean and the median. So if you want to get the statistics of these numerical data along with the categorical data, then you can use a box plot here. Okay, so the first this kind of the plot shows the 3 quartile values to the distribution. Let me show you how box plot work. You can say here box plot. Okay, and then quartile. Okay, sorry. Okay, the box plot quartile range. You will see here into images there is a maximum and there is a minimum, and then there is quartile 1 and then the quartile 3 and the median. Okay, so this is how it works in the box plot. Okay, we have outer fence, we have inner, that is first quartile 25%, and this is the minimum 25% quartile, and there we have most of the 50% data lies in between somewhere here. Okay, so let's go ahead and draw that box plot with the categorical plot, although we can do also with the box plot. So the sns.catplots, sns.catplot, then we have x is equal to the day, and then finally we have y is equal to the total bill, and then we have a kind is equal to box, and then we have data is equal to tips. Okay, perfect. Sorry. Now let's go ahead and see So if you make an analogy with this one, what we can see here is that these are the outliers in which the Seaborn has omitted while including these images, and this is 25%, 75% quartile. I mean, the most of the total bill, 75% of the bill has occurred less than 30, and this is the maximum bill, and here is the minimum bill, and this is the 25% of the data, and this is a total 50% of the data. And with this you can very quickly understand that the people tend to invest more on the weekends, and you see here these are the most of the data at the total bill are concentrated a little higher than Thursday and the Friday. Okay, and apart from that, as we have added the hue there in our earlier plots, we can also add hue here based on, let's say, a 6, right? And we can also add a hue based on the time as well, right? Perfect. So this is how we can add a hue into our box plot. Let's go ahead and see one more thing you might be wondering here. Once we add a hue semantic, the box for each of these variable moved along the categorical axis, so they do not overlap. Okay, and that behavior is called the dodging. Okay, that behavior is called the dodging, and let's say if you don't want that dodging, then we can make that a false. Okay, so let's go ahead and plot this once again. What we can set here, hue is equal to a time. You see here, sorry, we should get here the kind with box, right? So we have got a box with box, and there you see there is dodging. Okay, one more thing I think I am missing here. The data is the tips is right, kind is the box, hue is a time. So let's copy this and paste it here. We should get something like this. Here we have got a plot. Now what we get here, this is the time actually, lunch and the dinner, and if we do again a 6 here, you will see here. Okay, so let's set that dodging equal to the false. Okay, dodge is equal to the false. Okay, you see here now that dodging has been removed and all of these plot has been mixed in a single plot. And here you see here females are these are the a little bit more here, and this is kind of the overlap together. On the Saturday, the male and the female are almost have a, if you see it with the 6, then I can show you. So on the Saturday, male and the female almost invested the same amount of the money. Okay, although there is a little difference here, but these 50% quartile lies almost the same there. And if you see here on these stage, the male kind of have taken more food than comparison to the female candidates. Okay, now let's go ahead, and you might be wondering that you might feel that, okay, this box plot is not showing you enough information, and now you want to change this box plot to something else. Okay, so let's go ahead with the boxing plot. Okay, what is the boxing plot? Let me show you. We can go ahead with the diamonds data set. Okay, so let's first load a diamonds data set. Okay, diamonds is equal to the SNS dot load data set, and there I'm gonna load diamonds data set. Now once we have a diamonds data set, let's go ahead with the SNS, and then the cat plot where x is equal to color, and then y is equal to price, and then we have kind, and their kind is equal to box in, and we have a data is equal to diamonds, and then I'm gonna do a sort values there. Okay, I'll tell you what is the sort values. So sort values do a sorting based on the here color. Okay, now let's go ahead and plot this. You will see here what has been done here. Based on the color, the values has been sorted out. Okay, otherwise if we remove this, we will get, you know, something very weird actually. Sorry. This says that let's see the diamonds. What is the diamonds? So in the diamond we have also the color. Okay, yes, so these are the different kind of the color where we have, and we should pass this with this one. Otherwise what I can do, passing like this. Okay, perhaps this is saying that could not interpret as the input, but it has okay, so what is the problem here? It has you know, the color as well, but what happens here, the data which we had passed there, let me show you the sorted value first. Oops. Okay, so this one, right? It was this one. Perfect. Okay, so here it gets this data. Let's copy this and paste it here, right? So this gets the data, and it sorts the value based on the color. Okay, so it goes the D, E, F, G, H, I, J. Okay, so this is how it works. Let's say you might be wondering that why I'm doing this one, not doing this one. So what we can do, we can also plot that one. So for that, what we can do, we can set here a kind is equal to the box in. Okay, let's go ahead and set here a kind is box in. You see here now we have got something like this. And let's, if we remove a hue to get a better understanding, then you will get something like this. Okay, so with this box and plot we can make an understanding that most of the so this is the 50% of the total bill. Okay, so and most of the total bill are concentrating around somewhere this, and which is higher on Saturday and the Sunday, which is a weekend. Okay, so this is how you work with box and plot. Let me show you how you can work with violin plot. Okay, and that is a different approach, and which combine violin plot and the box plot. I mean, the violin plot is made up of KDE plot, kernel density estimation plot, as well as the box plot. Okay, so let's go ahead and see how violin plot works. So SNS dot catplot, and then we have here x is equal to total bill, and then here we have y is equal to the day, and then finally we have here a hue is equal to time, and then finally we have here a kind, which we are gonna set here violin plot. Okay, sorry, violin plot, and then we can set the data is equal to the tips. Perfect. So you see here this is a violin plot. Okay, and its a hue has been divided based on the time there. You see here we have the different color to the lunch as well as for the dinner. Okay, on the Friday most of the people have done a lunch instead of the dinner, but on the Saturday and the Sunday most of the people are, you can say almost all the people have done the dinner only, and the people had missed the lunch on that day. Okay, so this is how violin plot works with the horizontally. Although if you want to let's say what we can do, if we make a hue based on the sex, you see there are two separate the violin plot, and earlier we had something like a dodge, but here we have a split. Okay, so if you set here a split is equal to the true, then then what it does, it divides a single violin plot into a multiple violin plot. Okay, so this is how it works. It splits out a single violin plot into a multiple violin plot. Okay, perfect. So this is the way here we can work, and there are some other way where we can also work with the violin plot. I mean, we can also add there the palette as well. Okay, so to do that, what we can do, we can say that let me draw some lines here there. Okay, based on the total bill. Then we can say here inner is equal to stick. There we have a stick, right? You see there inner has, we have a stick. Okay, so these are the different way how we can do. Okay, so these plotting. And now we have seen that how we can add the box plot inside the violin plot and these bar plot kind of right, and rug plots, it's kind of the rug plot. Now let's go ahead and I'll show you how you can add a violin plot as well as swarm plots together. Okay, although violin plot is made up of KDE plot and the box plot, if you see it carefully, okay, if I remove this stick, if you see it here very carefully, this is a KDE plot and inside there is a KDE plot. Okay, sorry, inside it is a box plot. Okay, now let's go ahead and draw swarm plot and the KDE plot together. To do that, what we can do, we need to get an object of SNS plot, facet grid. Okay, so SNS catplot, and then we can pass x is equal to the day, and then we can pass here y is equal to total underscore bill, and then we can pass here kind, and this kind is here violin. Okay, perfect. Now we have here inner is equal to none. Here now we have a data is equal to the tips. Right, now here we have SNS dot swarm plot. Right, now here we have x is equal to the day, and y is equal to total bill, and then we have a color. Let's say color is K, that is black, and then we are gonna set here a size 3, and the data is equal to tips and AX, that's the axis. We are gonna pass G. Okay, so if you pass this, you will see here, sorry, AX is equal to G dot AX. Okay, that's the G axis. Okay, so you see here there is some kind of the error. It says that the kind violin is not recognized. Let me see here. This says that this is not recognized, sorry. Okay, now you see here inside a violin plot there is a swarm plot. Okay, so this is looking fantastic. Okay, there are so many ways in which you can actually visualize the data. Now this is how we have been talking about the combination of the categorical plot and the numerical plot together. Now let's say if you have any requirement to analyze or visualize categorical plot versus categorical plot. Okay, then how would you do that? Okay, so let's go ahead and see a Titanic data. We have a Titanic. Okay, we have already loaded that. So let's say we have here a survived. Okay, although this is the numerical data, but let's say how would you analyze this based on the different category. Okay, let's say different category like sex and the class. Okay, to do that, what we can do, sns dot catplot. Okay, but before that, let me ask you a question. Do you understand why we are doing these visualization, etc.? If you do not, let me tell you. With the visualization, we can get understanding on the data and the correlation or the relation amongst the variables. And once we get the full understanding of the data and the correlation between the variables, then we would be able to find out the best fit of a machine learning algorithms and the techniques which will be applied to our data. Otherwise, we will be working into a darkness. Okay, now let's go ahead, type here sns.catplot, and then we are gonna here type x is equal to, we have a 6, and then y is equal to, that is the survived. So that is also kind of the categorical data. Okay, and then here we have a hue, and we are passing class as a hue, and this is gonna be a kind of a bar plot, and then the data which we are gonna pass here, that we are gonna pass here Titanic. Let's plot it. So once we plot it, we see here that we have here a survived, and here is a sex, male and female, and the class. Okay, so with this, what we get some kind of the confidence interval. Okay, confidence interval between the male, female, and the class of a passenger. Okay, so if person is a female, okay, so it is very likely to survive. And if a person is female and first class, then there is almost more than the 95% possibility that person is gonna be survived. And if person is a female candidate and the second class, then there is around 82 or 83% of the survival chance. And if person is a female candidate and traveling into the third class, then its survival chance is around 50%. But you see here, if a person is a male category, then almost in each cases, okay, in each classes, its survival chance is always less than 50 or 40%. And this box and this lines represents that this is the probability of the error. Okay, so this says that there is 95% of the confidence that the survival would be something in between this and in this and in this. There you see here, there is very high, uncertainty. Since this line is very large, that's mean the uncertainty is large. But in this case, you see here uncertainty is very low. That's mean if female candidate and if it is into the first class, then definitely there is very, very high chance that person is going to survive. Okay, so now this is how we can see that the categorical plot is being made into a different the color of the bar. Let's say if you want a single color bar but you want to change the gradient of the bar, then how would you do that? Yes, it's a very simple. You can do with the SNS, then catplot. There you can say x is equal to dec, and we are gonna say here kind. Now we have count, kind is a count. Okay, so this is different kind of the plot. Now this is the count kind of the plot, although we have also the count plot as well. And then we have here, the palette. and the palette is equal to ch 0.25, and then we have a data is equal to the Titanic. Okay, now let's go ahead, and now you can see here the palette is 0.25, and if we change this palette we get something like this. Okay, so in this way we can change the palettes and we can get the same kind of the color, but like a gradient color. Okay, light to dark. Okay, and this is the deck and the traveling person. So in the C deck most of the people were traveling, and B, C, D, E deck most of the people were traveling, but in the G deck there are very less number of the people who were traveling. Okay, now let's go ahead and work with the bar plot. Okay, perfect. So the bar plot and count plot can be invoked with all of the options discussed above, like a categorical plot. Okay, where we can set just the kind is equal to the count, or a bar plot. In that way it can be done. Okay, so the moreover this can be either you can say a bar plot or a count plot. Okay, so it doesn't matter much, it's the same way. Okay, perfect. Although we can also set here a hue there. So if we set a hue is equal to, let's say, a class, then you will see something like this. Okay, so these are the third class. Okay, so the deck A, B, C, so these decks were mostly dedicated to the first class passengers, and deck D and the E were distributed in between first class and second and third class, and the G deck were mostly for third class passengers, and I believe that that was one of at the lowest level. Okay, perfect. And these deck ABCs, I believe that it was at the top. Okay, that's why perhaps you know, the first class passenger were more tend to survive there. Okay, their probability of survival were really high. Okay, so this is how these plots work. Now we have been doing a lot of the categorical plot with the bar plot and count plot, scatter plot, etc. But there is also another plot into the market that is known as a point plot. Okay, an alternative style for visualizing the same information can be offered with the point plot as well. Okay, so this point plot also encodes the values of the estimate with the height of the other axis, and rather than just showing a full bar, it plots the point, and it also find out the confidence interval. Okay, and with the point plot it would be really very understandable to find out the slope there. Okay, let me show you. Let's say here we have the survival against the sex and the passenger class, right? We can see here and understand with the bar plot, right? But there is another way in which human eyes can make a better judgment. Okay, that is a point plot. Let me show you how. Okay, so let's say you have sns dot catplot, and then we have x is equal to this x, and then here we have y is equal to survived, and then finally here we have a hue, and in the hue we have a class, and then finally we have here a kind, and in the kind we have a point, right? And in the data we are going to pass a Titanic, right? So with this you will clearly see that if person is a female candidate, okay, as compared to the female, if person is female candidate, okay, if traveler, you can say, if a traveler is a female candidate, then definitely there is very high chance she is going to survive. Okay, so this is what point plots do. Okay, and and this is all about into our categorical data plot. Now I'm gonna take you to the another section that is visualizing the distribution of the data. Okay, so let's copy it and go ahead. Okay, so here now we have a visualizing distribution of the data. Now we have seen how we can plot numerical data versus another numerical data. Now we have seen how we can plot numerical data versus categorical data. Now I'm going to tell you how you can understand and visualize how the distribution of the data has been done. Okay, how it is distributed along the another variable. Okay, perfect. So we are gonna first plot a univariate distribution, and most convenient way to take a quick look at univariate distribution in Seaborn is to use a distribution plot, which is in short known as a dist plot. Okay, so by default this dist plot draws a histogram and fit a kernel density estimator, okay, on that histogram plot. Let's go ahead and create a random number x, okay, is equal to we have a random already. Okay, so let's go ahead and create here a random with the size 100. Okay, and once we have a x, let's do sns dot dist plot and then finally plot this x and see what happens. Okay, so here we have our plot which is a distribution plot of the x. So by default its kind is a histogram and it has a KDE plot. Okay, you might be very familiar with the histogram. Okay, and we have already used hist function in our Matlab plot library that we had used plt.hist. A histogram represents the distribution of the data by forming bin along the range of the data and then drawing bar to show the number of observation falls in each of these bins. Okay, so around this bin 0, around this number of the observation were false. Okay, and overall the area under this curve is always 1. Okay, that is why it is known as a normal distribution there, right? And we can also remove this density estimator function by just passing KDE equal to the false. Okay, KDE is equal to false. Now we have removed that kernel density estimator. Even you can place your cursor in between these parentheses and press shift and the tab, and then you will see here by default KDE is a true and histogram is a true and the rug plot is false. Okay, so what we can do here, we can set here rug is equal to the true. Okay, now you will see here there is a rug plot also. Okay, perfect. Now you see here this number of bins is being automatically decided by Seaborn. To control this bin, what we can do, we can pass here bin. Okay, so there we have a bins. Now pass this bins here. Let's make a 30 total. So here we have a total number of bins is 30, right? Perfect. Now let's go ahead and just plot only the kernel density estimator. Then how we can do that? We can make it true and then we can make hist is equal to false, and you see here now we have only the kernel density estimator, right? Perfect. What we can do here, we can also make this rug plot false, then you will have only the rug estimator. Okay, right, perfect. So the drawing this KDE is more computationally intensive involved than just drawing a histogram. What happens actually, a normal distribution is being calculated for each of these distribution, and once normal distribution is calculated for each of the value, and then after that that normal distribution is being summed up, and then finally it is being normalized, so that the area under the curve should be always 1. Okay, that's the beauty of normal distribution. Okay, now let's go ahead and see this plot by using KDE plot. What we can do here, we can pass here sns dot KDE plot, and then we are going to pass here data x, and then I'm gonna pass here set is equal to the true. Okay, you see here there is a little difference there. Sorry, this should be the set. There is a difference. Okay, so the shade is the true, that's why it has filled up the shade with some, you know, the transparent color. Okay, although we can press here shift and the tab, we can set we can see other parameter like vertical is false. If we set vertical true, now it will become a horizontal plot. And then there is a grid size and the cut, clip, legends, etc. There are so many things. Okay, like C bar, right? C bar, it is saying that the C bar is a false. We can set here C bar, is equal to true. Okay, although we do not have any gradient here, that's why C bar is not coming there. Perfect. Now let's go ahead. Now you see here, this is a very smooth KDE plot. Okay, and we can now control this bandwidth by setting BW. Okay, that is the bandwidth. You see here, you see here this BW, the bandwidth. If we set here the bandwidth is equal to, let's say, somewhere 0.2, then what happens? Okay, let's set BW is equal to the 0.2. Now you see the bandwidth has been changed to very low. Okay, and if we increase this bandwidth to the 1, then you will see here a very smooth curve. Okay, although this curve is not like this one. Okay, so this is how the bandwidth changes the shape of a KDE plot. Okay, apart from that, if we pass here a cut parameter, let's say the cut is equal to the 0, you will see here cut is something like this, and if we make cut is equal to the 10, then we will get something like this. Okay, and if we pass, let's say the cut is equal to something 5, then we will get something like this. Okay, so the cut 0 will cut it. Okay, so the cut its plot, and moreover you can say this has zoomed this plot somewhere like this. Okay, perfect. Now let's go ahead and see how we can plot a bivariate distribution. Bivariate, I mean to say that you by saying a bivariate means there would be a two variable which we will be plotting, a x variable and a y. Okay, x-axis and the y-axis. Okay, so for this, what we are going to do here, we are just going to bring our tips here. Okay, so we have tips with head, right? And now we are going to read it into x variable, this total bill. Okay, so that's the tips, and then we have here a total bill, and similarly I have a y, which is equal to y. We have y, let's say y is equal to the tip. Okay, perfect. So now we have x and the y. Let's go ahead and plot it. Okay, perfect. So here what I'm going to do here, although I don't need to put it into the x and the y, let's go ahead and just plot a joint plot, okay, between these two variables, okay, total bill and the tips. So I'm going to do here sns dot joint plot, and then I'm going to pass here x is equal to the total bill, or I can just simply pass here x is equal to the x and y is equal to the y. Okay, now you will see here a joint plot, which we say in general as scatter plot, but here there is extra information. Okay, this is not like earlier what we had seen. Now we have a lot of the control which we can control these plot as well. Okay, these line types as well. So let's go ahead and very quickly copy it. I'm gonna just copy it and paste it here. Once we have our x and the y variable, then we are gonna say here a kind is equal to the hex. Okay, so you see here now it is a hex. Okay, so it comes very best suited when we say our the style on a white background. Okay, so we can say here sns dot sns dot access style. Okay, so we have here sns dot access style, there we have it white. Okay, now let's go ahead. You see here, although it is not changing this, so by default it has taken that one. So for a time being, what we can do, we can just make it by default. Okay, sorry. Okay, perfect. So this is how we can change this the points. Now it has become a hex bin plot. Okay, perfect. Now let's go ahead and see it into another format, which is known as a kernel density estimation. Although we have earlier seen that, but not for the joint plot. Okay, so we can go ahead and we can do like sns dot joint plot, and then we can say here x is equal to x, and then finally y is equal to y. Sorry, oh my bad. Okay, x is equal to the x, and we can say y is equal to the y. Okay, and then finally we can say here the kind of the function which I'm gonna plot here, that is a KDE. Okay, now you see here we have a KDE plot. Okay, so this is for a bivariate, and similarly we can set here moreover very a continuous and dense plot. Okay, so let's go ahead and plot this KDE plot in a little different way, with f and ax is equal to plt dot subplot. Okay, there we have a fig size is equal to 6. cmap is equal to sns dot cube helix palette, and then we have as cmap here. Okay, so as cmap is true here, and I'm going to define dark is equal to the 0, and then I'm going to define here light is equal to 1, and then finally I'm going to say here reverse parameter to true. Okay, now let's go ahead and do SNS KDE plot. We have now SNS KDE plot. Here we have a figure size. Let's go ahead and set here x and y, that is the x and the y, and here I'm going to just pass here cmap is equal to the cmap, which I have earlier set here, cmap with cubic helix pattern, and then number of labels which is going to be the plotted here, that we can get n underscore labels is equal to the 60, and then finally we can get with shade is equal to true. Okay, perfect. Let's go ahead. Now you see here, this is how we can plot it. You see here the total bill, the somehow it is moreover, you know, very the bright light is here somewhere in between 10 to 20, and most of the total bill lies somewhere here, and the tips given to the waiters lies in between somewhere 2 and the 4. Okay, there is another way which we can use very nice and fantastic plot. So what we can do here, we can get with the g is equal to the SNS dot joint plot, and then then we can plot here x and the y, and then finally we can plot here kind is equal to KD, and then finally we can say here color is equal to M. Okay, now we have got a G, and you see here. Okay, now let's go ahead. We have got a G. Now we are going to plot another plot which is known as a collection plot. Okay, a joint collection plot there, and then that will be I mean a very good plot. Let me show you. Okay, just G dot plot underscore joint. Okay, G dot plot underscore joint, then we can say the PLT dot scatterplot. I want PLT dot scatter, and here C is equal to the W, and then S is equal to the 30, size is 30 there, and then we have here line width is 1, and then we have a marker. Okay, now the marker is here plus. Perfect. Now let's go ahead and do the G dot AX underscore joint. Now what I'm going to do here, I'm going to join the axis, x-axis, with the collections. Okay, perfect. And then I'm going to set here the alpha, that is the transparency. Okay, so alpha is 0 here, right? And then I'm going to set here axis label. I think I can omit that axis label. You see here, this is how beautiful this plot has been plotted out there. So we have got it here, a very beautiful plot. Okay, perfect. So this is how you can plot two plots together into a KDE plot. I mean, by using a joint plot. Okay, by returning an object from a SNS plot. Now let's go ahead and see how we can visualize a pair plot. Okay, so what is the pair plot? To plot a multiple pairwise bivariate distribution in a data set, you can use a pair plot. Sorry, I'm really sorry. So this creates a matrix of axes and shows the relationship for each pair of columns in a data frame. By default, it also draws the univariate distribution of each variable of the diagonal axis. So for example, let's load an iris dataset, which we already have. I'm going to just print that iris dataset so that it can refresh your memory. Here we have a 4 numerical column, and let's plot a pair plot using SNS pair plot. There we have SNS pair plot, and then pass here iris data frame. Once we pass here iris data frame, we will see here there is the correlation between the column wise. Okay, so you see here the petal width and the sepal length, petal width with the sepal width, so they are so much. Okay, so by default, what pair plot does, pair plot takes the diagonal elements which is a univariate and plot it into the bar plot, and it takes non-diagonal elements, non-diagonal and the plots into a scatter plot. Okay, although we can change this the plot types, we can change by returning object from the SNS pair grid. So we can say here SNS pair grid, and then I'm gonna pass here iris dataset, and then I'm gonna call here the map g dot map underscore diagonal, that's the diag, and then I'm gonna say here SNS dot KDE plot. Okay, perfect. Now you see here these the plot has been plotted as a KDE plot. Okay, now apart from that, let's plot off diagonal elements, which we can do g dot map underscore off diag. These are the off diagonal elements, SNS dot KDE plot. Okay, SNS dot KDE plot, and I'm gonna pass here number of labels. Okay, so the number of labels is equal to, let's say, the 10. Okay, since we have passed number of label 10, that's why it is taking a little bit more time. Now you see here, this is a different kind of the plot. Okay, so this is how we can work with the visualizing the distribution of any data set. There are so many ways in which we can visualize a given data set. Okay, now let's move ahead, and now we are going to do visualization of a linear relationship between the data sets. Okay, and if you remember, initially I told you that let me bring you here. I told you we will be talking about the regression plot here. Okay, the mostly the reg plot and the LM plot. Let's copy it and paste it there. Okay, so here we have, now we have a linear regression and a relationship. Okay, now let's go ahead and work with this one. First of all, that you might ask a question, why do we need a linear relationship visualization? You know, the many data sets contain a multiple quantitative variables, and the goal of the analysis is often to relate those variables to each other. And previously we have discussed about the categorical plotting and distribution analysis, etc. Okay, we haven't discussed about any linear relationship between the two data set. So in this the module, we are going to discuss about the linear relationship. You might have heard about the regression. Okay, so let's go ahead. Now what I'm going to do, I'm going to do analysis on the tips data. So here let me remind you tips data very quickly with the head. So here we have tips. Now I'm gonna get some analysis the tips versus total bill. Okay, so how total bill and tip is correlated, what is the linear relationship between the tips and the total bill. Okay, so go ahead and you need to type here SNS dot reg plot. Okay, so we have here SNS dot reg plot, and then we have X is equal to here total bill. Okay, and then finally we have Y, and the Y is equal to the tip, and then finally we have a data, and the data we have a tips. Right, you see here the very fantastic. Now earlier we have been just making a guess, like there is a relationship between the total bill and the tips, but now we can see here clearly there is a huge relationship between the total bill and the tips. Okay, so there is a tendency that if total bill is increasing, then the tip will definitely increase. Okay, I mean there is very high probability that the tip will increase, although that is not 100% sure. Okay, although there is another methods available to do the same things, that is using LM plot. So we can do the LM plot, linear model plot, and X is equal to a total bill, and then we can pass here y is equal to tip. Sorry, we need to also pass here data, so let's pass a data. Sorry, I'm very sorry. Now we need to pass here data is equal to the tips. Okay, so let's go ahead and see here. We have almost a similar kind of the graph, only there is just the figure size changes. Okay, otherwise this regression res plot and the LM plot is almost the same, but there are a few differences which I'll discuss later in the detail. Okay, now let's go ahead and see and plot the tip and the size of the person with the LM plot. Okay, so that is the SNS dot LM plot. Then here we have x is equal to the size, and then we have here y, and then y is equal to the tip, and then finally we have a data is of course the tips. Okay, perfect. Now you see here, as size is increasing, there is very high chance that the tip will increase. Okay, so this is some kind of the linear relationship between the size and the tip as well. But one thing you might have noticed that these numbers are in a straight line. What you can do, you can create a jitter around this axis, and for that you need to put here x underscore jitter is equal to the 0. Let's say 0.5. Okay, now you will see here there is a little jitter around this vertical axis. Okay, perfect. Apart from that, there is a second option, is to collapse over observation in each discrete bin. Okay, and then we can plot here a straight line which will show that okay, this is the confidence that this line has been, I mean this is the possible error, okay, can occur. Okay, so let's go ahead and do that. To do that, we can do SNS dot LM plot, and then we can say the x is equal to size, and then we can say here y is equal to tip, and then data is equal to tips, right? And then finally we have x underscore estimator is equal to np dot mean. Okay, now it will calculate the mean and it will draw a line according to the mean. Okay, so these are the mean to this data, and you see here for this line this is a mean, this mean, here is a mean. Okay, and similarly we can set here a median as well. Okay, so these are the median there. Okay, so this is the way how we can work with the LM plot here, right? Now let's see if we have here a linear relationship, a data which has a linear relationship. But let's suppose that if we don't have a linear relationship, okay, then how we can fit it. Okay, now let's load another data set known as nscomp. Okay, so we are going to load it into the data, and then the SNS dot load data set. We have this data set nscomp, and then it has returned into the data. Let's do SNS dot LM plot. Okay, but before that, let's visualize this data. Let's understand what is this data. Okay, with the head. Now we have a data set x and the y. To understand it into the better way, what we can do, we can say here the data and then the data set finally, and then we can do here value counts. Okay, now you see here there are 4 types of the data available there, and each type of the data contains 11 values. Okay, now let's go ahead, do SNS dot LM plot. There I'm gonna give x is equal to the x, and then pass y is equal to just y, and then data is equal to the data. And apart from that, I'm just gonna plot here the data set which has the data type 1. Okay, So to do that, what I can do, I can query that data set with the query data.query, and then I can say here, if this data set, okay, sorry, I need to put it into the double colon, if this data set is equal to I, okay, so that is a data set 1, okay, perfect. Now let's go ahead, and with this I'm gonna create here ci is equal to the null, and then scatter keywords, I'm gonna just pass here a little scatter keywords with the s is equal to 80, okay, perfect. Now you see here, this is the linear relationship. This has shown a linear relationship between these points, okay. Now let's go ahead and plot the data set 2 and see what happens, okay. So now if we plot data set 2, we see that it has also fitted a linear graph in between x and the y, although we can see that this is not a linear relation, okay, in between x and the y. So there is some kind of the polynomial relation, okay. So we need to understand that is what kind of the polynomial relation is that. So to fit it into the polynomial, we need to pass a parameter, okay, that is the order, okay. Although if you don't know how I'm selecting these parameters, you can press shift and the tab, you will see there are so many options are available here, okay. So I'm just gonna set here order. Let's go ahead and the set order. Now I'm going to set here order is equal to the 2, okay. Now if I plot here, I can see here it has fitted this plot very well, okay. Now if I pass here order is equal to the 3, then you will see here it has also fitted it very well. Now if I pass here order is equal to the 1, now you will see here there is just a straight line, okay, perfect. Now let's go ahead and see how our data set or linear plot or any plot fitting is being affected by outliers, okay. Let's go ahead and plot our data set 3 here. Now we have a data set 3 here, okay. Now you see here there is just the outlier, and because of this outlier, this fitting has shifted to this one, okay. That means there is very high chance of the error. To remove this fit, what we can do here, we can remove that outlier, okay. Either we can do manually in the data set, remove this outlier, otherwise we can pass here parameter robust, okay. So this robust, if I set here this robust is equal to the true, then it will automatically calculate and it will find out that okay, this is an outlier, and it will remove that outlier and it will fit a perfect straight line that will show a linear relationship, okay, perfect. Right. Now this is how we have been fitting a linear relationship between the two variables and the polynomial relationship. Now similarly, let's go ahead and see how we can do with the conditioning on the other variables and understand how it is being plotted, okay. To understand this in a better way, what I can do here, I can do sns.lmplot, and then x is equal to the total underscore bill, and then y is equal to tip, and then finally data is equal to tips, right. Now you see here it has a perfect fitting, okay. Now if we pass here a hue, let's say a 6, now you will see something kind of the different the fitting there, okay. So one has for a male and another one has for a female, and similarly we can set a style as well, okay. And apart from that, we can also set a marker for all of these the settings. Okay, so let's say a marker. We have now markers. Inside the markers we have a circle and then we have a cross. Okay, so let's go ahead and see here. Okay, for a male we have a circle and for female we have a cross. Okay, perfect. So this is the way how we can do, and there are a few more things which we can visualize by setting the column. Okay, so now let's say a call is equal to the time there. Now it will divide the time into lunch and the dinner, and accordingly it will set. Okay, now let's divide row as well, and now I'm gonna divide row into a smoker. Okay, now you will get here rows has been divided into the smoker. So the first one is a smoker yes, smoker yes, and smoker no, and smoker no. Okay, and the first column is for a lunch and the second column is for a dinner. Okay, perfect. So this is how we can do it, right? Now you might be wondering how we can control the shape and aspect ratio of these plots. Okay, these things are really very simple. To do that, what we can do, we can just call a subplots of the Matplotlib. Then we can return f and the axis, that's in the figure and axis object. That we can do the plt dot subplots, and in that we can set here a fig size. Okay, and there I have a fig size which is 5x6. Okay, and then I need to pass here axis, that ax is equal to the ax, right? Now this says that lineplot got an unexpected the keyword, although I don't need this. This can be done with the regplot actually. Sorry, this says that unexpected keyword a hue. Okay, we don't need a hue. I think what we can do here, I can first remove this, then we should go ahead with this one, and this is the 5x6. Okay, now let's go ahead and see 8x4. Okay, you see here now we have the figure which is set by 8x4. Okay, perfect. If you want to see what are the parameters which regression plot accept, these are these parameters which regression plot accepted. Okay, perfect. So it doesn't accept hue and other things, although the lineplot accept. Okay, does it? So lineplot doesn't the accept axis. Okay, does it? I don't think it has axis. Okay, so these are some differences between the lineplot and the regplot. Let's go back to the regplot. Perfect. And apart from that, let's say we have a high number of the plots. Okay, let me show you first. Okay, sns.lineplot. Although we have seen this kind of the plot, but still I just want to remind you how you can do this. The total underscore bill, and then y is equal to tip, and then data is equal to just tips. Okay, if we plot this like this, and let's say we have here call is equal to day. Okay, now we have here 4. Okay, the Thursday, Friday, Saturday, and the Sunday. But let's say if you want to set this into a 2x2 matrix, then how you can do that? To do that, you can set here a call wrap. Okay, so just call this call wrap is equal to the 2. Now you will see here this will be okay set into the 2x2, although you will get a control to set its height as well. Now you can set a height is equal to, let's say, the 4. Okay, now we have set a height to the 4. Okay, perfect. So this is all about working with the linear relations, and now let's move to our final part. And our final part was, if you remember, that to set the figure aesthetics and the color, etc. That is controlling plotted figure and the aesthetics. Okay, perfect. So let's go back there. Sorry. Okay. Now let's go ahead and press M on your keyboard and then paste it here. Now we have a controlling how we can control plotted figure aesthetics. You know, the drawing attractive figure is important. When making figures for yourself as you explore a dataset, it's always nice to have a plots that are pleasant to look at. Visualization are also central to communicating quantitative insights to an audience, and in that settings it's even more necessary to have a figure that catches the attention and draw a viewer in. Okay, so the Matplotlib is highly customizable, but it can be hard to know what settings to tweak to achieve an attractive plot. So the Seaborn comes up with the number of customized themes and a high level interface for controlling look of Matplotlib figures. Okay, now let's go ahead. Now let's go ahead and create a plot which have a lot of the sinusoidal signal. To do that, we are going to do create a sine plot with, let's say, a parameter flip is equal to 1. Okay, this is a Python method or a Python function, you can say. Here we have x is equal to np dot linspace, and that linspace is 0 to 14 and set to 100. Okay, and then we have a for I in range is equal to 1 by 7. Okay, plt dot plot x is equal to the np dot sine and x plus I. Now let's multiply this I by 0.5, and then let's multiply another something 7 minus I. Okay, and then finally multiplied by flip. Okay, so this is how we get this sine plot. And now let's call this let's call this sine plot. Okay, now we have here a sine plot. It has plotted these plots, okay, these lines. So it has run almost let me see here, what is the linear space? Linear space says the start and the stop, there are 50. So there are 50 points, and it has run 7 times, and it has a total 100 points for each x, and it is being plotted here. Okay, right, even though if we pass here -1, it will plot here as something else. Okay, perfect. Now let's go ahead. Now let's go ahead and see how we can do a figure styling. Okay, first of all, that we are going to set a white grid there, sns dot set style. Okay, if you press here shift and the tab, you will see here a style. We will get a different kind of the style. Okay, by default we get the dark grid, but we can also get dark grid, white grid, dark, white, and the ticks. Okay, so let's go ahead and set here white grid. Okay, perfect. Now plot this sine plot. Now we have here a white grid, okay, with the sine plot. Perfect. And similarly, we can go ahead with the dark here. If we go with the dark, even though we can go with the white only. So these are the way in which we can control, right? But one thing you might be also noticing here, that there is no ticks on these axes, and if you want to put a ticks on those axes, you can call a ticks. Okay, so once you call a ticks, you will see here these are the ticks has appeared on those axes. Okay, one more thing you might want to do, that the boxes or these axes are not necessary. Okay, to do that, what you can do, you can call sns.despine. Okay, so once you call a despine, it will remove this upper and the right hand axis. Okay, So this one now looks quite good plot. Okay, perfect. Now the some plots are benefits from the offsetting the spines away from the data, right? Let's say if you want to remove this left spine as well, then how we can do that? We can say here left is equal to true. Okay, now we have removed that left as well, right? Let's say if you want the bottom as equal to the true as well. Okay, now we have removed the bottom as well. Okay, now let's say if we set it to white, right? Now you see here we have got like this. Perfect. Okay, perfect. Now let's go ahead. This is how we can set it. Okay, now let's say how we can override the element of a Seaborn. Okay, do you understand the element? I mean any kind of the element. Okay, how we can get those elements? We can just call here sns.access underscore style. Now you will see here these are the current element which is being set on our the current plot. You see here it has axis face color white, edge color is 0.15, axis grid is false, although we can set here axis grid is equal to the true. You will see there a grid will be there. Okay, how we can do that? We can just simply pass here inside this style, set style there with the dictionary. There we have here access dot, right, dot grid is equal to the true, right? Now you see here we have got a grid, right? And similarly we can pass a dictionary for something else. Let's say you want for a color or a line style. Okay, let's say you want x tick direction. Okay, let's say you want x tick direction control. Then how you can do that? You can just copy this here, x tick direction, and you can paste it here, and then you can set it here in. Okay, now you have x tick direction in. Okay, if we set it to false, then you will be able to see it. Okay, now you see here x tick direction is inside, right? So this is how we can set different kind of the the elements. Okay, this is the beauty of the Seaborn. It gives you a full control to give a very nice aesthetics to your figure, right? Perfect. Now let's go ahead and see how we can do a plot scaling, right? By default, if you see here, these texts are quite small. Okay, and these texts are not good fit. Okay, let me show you what I'm talking about. Let's again call here a sign plot. Now you see here these texts are really very small. Okay, and sns dot set underscore style, and then I'm gonna set here dark grid. Okay, perfect, right? So these texts are really very small. How would you make sure that these texts come to a really big, and we should be able to see it very properly? Okay, so the Seaborn provides a method or a function to set it with sns.setContext. Okay, with set context. So here with the set context we can say here a poster. Now you see here for a poster it is quite big. Okay, and there are so many other available, like a posters, like a talk, and the paper. If we set here a paper, we will see like this. If we see set it to the talk, you will get like this. Okay, perfect. And apart from that, we can also control a font scale a little bit more. You can press a shift and the double tab, you will get all other parameters like a font scale and other parameters, RC. Okay, so let's go ahead and set here a font scale is equal to the 1.5. Now you will see here the font has been increased, right? Perfect. Now let's go ahead and finally see how we can control the color palettes and what are the color palettes are available. Okay, that will be really very quick. I can understand it has been almost the 2 hours and the 50 minutes while watching this tutorial. So let's go ahead and I'll set you some color palettes which are the Seaborn uses. Okay, so if you want to know the current color palettes, then how you can know that? With this you can know the current color palettes. Okay, is equal to the SNS dot color palette, right? Now if you type here SNS dot pal plot, you will see here current palettes. Okay, sorry, this should be the double R. So this is the current palette. Okay, this is being used. So the first color is being used, the blue, another one is the orange, and then the green, and then red, and then these colors are coming. Okay, once these colors are timed out, then this will again come back in the circle and it will come back to this blue color. Okay, so this is how this is being used. Okay, there is another way where we have a circular color system that we can also see here with the SNS.pal plot. This is known as a palette plot. Okay, with the SNS dot color palette with the HLS and set to 8, let's say. Now this is another kind of the color which we can use into our color palette. Okay, so these are the way in which we can use these color palettes, etc. Okay, although there are a lot of the things are available to explore into the Seaborn, and this is the what I could have covered in the 3 hours. This seems almost the complete kind of the tutorial. Okay, I'm sure it will definitely help you to understand better data visualizations into the Pythons, and it will help you into your machine learning journey. Thank you so much for watching, and thank you so much for being with me for this long, almost for 3 hours. And please do not forget to subscribe this channel, and please do not forget to like this video. I have invested a lot of the time to make this video. Please do not forget to subscribe this channel and like this video. Bye bye, have a nice day.